Hello my fellow activists, welcome back to the Kerbal Space Programme with me, The Revolution, your host, Swordcorn today. So here we are, we're back in, we're going to jump straight into the spaceplane hangar today. We're looking at some single stage to orbit ships today, a bit of an SSTO is I believe what's called in the KSP community. So here we go, we're jumping into the spaceplane hangar and we'll start off with our first design today. Now this first design was actually sort of based it on a bit like one of the X-Wings from Star Wars. So I've got one of these new cockpits. I don't know what version they were released with, but they've got that ring to it. But it's not going to be exactly the same. I've sort of taken my own spin on it because I want to keep it light, but make sure it can actually do what we need it to do when the time comes. So obviously we've got that in place there. So we'll place on the square wing connector so we can sort of get an idea about how it sort of comes out from the actual craft itself. That's not really the direction I wanted them to be on, but that's the best way that they will go on by the looks of things. So it'll have to do. So we'll just use one of those there and we'll place on another wing connector. There we go. That's what I wanted to do. I wanted to tilt one down just on the outside there, just to make it look a bit more like a bit of a wing there. It sort of points down. So anyway, now the next thing I want to do, I need to get some form of propulsion. Obviously, what I would like to do is I want to mount it underneath these wing connectors. Now, due to the way that KSP works, that would be a bit of a pain. And I sort of, if something goes wrong, I sort of want to be able to get rid of them at short notice. So, one hit of a button on an action group and we've lost those. Because obviously that's going to keep the pilot safe, and hopefully we can avoid any issues with burnouts and other bits and pieces if we decide to use atmospheric engines. So anyway, the first plan I had here was a Clampotron. Obviously, use a couple of docking ports, then stick it on an action group, and bang, it comes off. But that does not work. Obviously, due to the orientation and the way that certain parts work, that wasn't an option. So obviously, we've gone with these. Decided to go with these hydraulic detachment manifolds instead. Now, obviously, when I first started designing this, I was using my laptop mouse pad that was actually built into my laptop. So this slight pause here was due to me rooting around looking for my USB mouse, so I can actually do things with it in a bit more detail. It makes building a bit easier to use an actual mouse. Okay, so back here with USB mouse. Okay, so let's grab these manifolds and we'll line them up so they're actually straight. Oh, excuse me, that bunged up nose is still not going anywhere. So let's place on some liquid fuel there. Okay, so I sort of placed on a structural fuselage just to see what that would look like. Okay, now I'm going to place some probes on, because they could sort of double as like emergency missiles as well. It's like a very last minute resort thing if they were to be attacked when they're out in space. Obviously, the best way to do that if we're in space in that case is to use liquid oxidizer. So we have the actual rocket fuel in there. Because obviously liquid fuel on its own when you're in space is not going to do anything, because there's no oxygen in there to actually set a light, so your engines won't fire. But at least with the liquid fuel oxidizer, we've got some fuel to play with. So we'll use another hydraulic detachment manifold, slightly bigger one. Because the plan I sort of have is a bit of a sort of a miniature two-stage one. We'll have a large stage rocket to sort of break through the initial atmosphere, get us up to the height we sort of need, and work on some of the horizontal planes. And then obviously, if need be, we can then drop that and use the two currently hanging off the side to complete whatever manoeuvre we're currently trying to do, and obviously anything we may need to complete in space. Refueling of this in space would be an issue with this current design. There's obviously no docking ports, and obviously if it ever was to make it into space, then something is going to have to come up and refuel it at some point. That's the only downside of using two small engines. But just in terms of while we're testing, I thought it was a fairly safe design. So I'm going to try and launch and get actually straight up as if it was a normal rocket first of all. Because if we can get it off the ground by launching directly up, then obviously we can gain a bit of height going vertically using the rocket max thruster, and then hopefully tip over as if we're going for a genuine launch, and then use the rest of the momentum to sort of try and push ourselves out of the atmosphere as much as we possibly can. trying to keep it as as few stages as I possibly can here. So here we go. We're going for our test launch in 3, 2, 1. Launch clamps released, and we're flying backwards. Yeah. Don't see that in real life. Now, in real life, in this sort of design, when rocket ships are actually designed, we've all seen the basic design. There's a shuttlecraft, and it's sort of like hooked onto the main fuel tank, that big orange one, and then obviously on the side of the 2 orange ones we have 2 smaller ones, and that's a 3-stage rocket. That's how we human beings break out of Earth's atmosphere. It takes a lot of power. Obviously, it's obviously you're just moving through atmosphere and you're moving through air, but the laws of physics do apply. And when you're trying to move fast through a thick layer of atmosphere, it's basically like trying to move a submarine underwater. You're trying to push something through water as fast as you possibly can, but you're going to get that resistance, and so you really have to sort of plan everything you're doing to sort of get through that. And obviously single stage to orbits are a massive advantage because you don't have to fight the atmosphere as much. You can actually use the atmosphere to your advantage to gain speed, gain height, and before you even left the atmosphere you've basically got your orbit. So all you need to do is at the last minute, when you're basically skimming along the bits of the atmosphere where you've got the least amount of resistance, you will just shoot up, and obviously if all goes well, you can actually then bring them back down, and it's reusable. You can use them as many times as you want. So they do have lots of advantages. Now obviously I'm just trying to do a bit more of an actual takeoff here using some launch clamps, just a bit more of a horizontal one. That doesn't work. Yeah, you can probably tell why, but it was due to the weight. Obviously, the amount of weight in those fuel tanks, just dragging it to the floor, nothing could be done about it. So obviously, there is no way I can launch it in this configuration. Now, obviously, I could always try and just drive it as if I was just trying to launch a jet. That may be an option. So let's place some landing gear wheels on and sort of give that a go. So let's place a couple on the front and a couple on the back. It's not majorly important the orientation that they're in. It's literally just sort of get us moving a little bit. Then obviously, when we get to a certain speed using the Rocket Max fuel busters, and obviously I will detach from that and just see how far the craft actually gets. The biggest oversight on this build is I didn't put any control surfaces on the wings, so even if I was able to make this craft work, it was never going to lift off because there was nothing to actually give it any lift or control whatsoever. It was literally just a rocket. So zooming it down a runway like this, even if it had worked, was never going to take off because it was literally generating no lift whatsoever. It was just literally generating horizontal speed. I was basically just driving a car, and every single time I was driving that car to its doom. And there you go, that's why. The centre of thrust is literally throwing it onto the ground. It's not going anywhere. So, but we don't need that Rocket Max fluster. What I was thinking of doing is actually just using that as a bit of a launch, like a bit of a launch pad, and just detaching from it and then firing off the engines and just going and seeing how far that could possibly get us. So that's the plan this time. So wait for the physics engine to kick in, throttle up in 3, 2, 1, detach, fire. Well, we finally got up into the air. We just killed our pilot and took the other wing whilst we were at it. So I think it's probably time to call this design a day. I don't think this one's going to get us anywhere. So, but I just want one more go with just this, literally just this, nothing else. I want to see if this can actually get itself up into the atmosphere. Again, I don't know why I spent so much time on this craft without any control surfaces. I was never going to take off in a million years. But there you go, I just kept on trying, apparently. I wanted this design to work, but the massive oversight of no control surfaces. It's easy to pick apart your mistakes when you're actually looking at this as we are, after it's been done, but when you're actually playing the game and you don't think about it, you don't do it. You just assume you've got your design, you want to give it a go. A couple of things are going wrong, so you just try different things. It's literally a case of just trial and error. And the biggest error I made was not putting any control surfaces on, but that's beside the point. Now, obviously, moving back to actual the spatial mechanics. Now, moving along a runway like this is a lot more beneficial. Obviously, you can build up speed whilst you're on the actual planet's surface. You can take off like a normal plane. So obviously this doesn't work, but as approved in the first ever look at the Kerbal Space program on this channel, that obviously you can actually, you know, taking off and moving through the atmosphere, building up speed. It's a lot easier to do when you're actually going at a horizontal. If you're actually trying to fight your way up through a layer, I mean, the best way to describe it is the ocean. If you're at the very, very bottom of the ocean, the pressure down there and the force it would need to break your way through, then get back to the surface, would be ridiculously difficult. It would take so much of your effort. But as you got further away, and as you got closer to the surface of the water, it would become easier and easier and easier, and finally you would break above the surface. You're out of the water, and all of that momentum is just literally, it's just carried you there. Whatever's left will just literally make you float, and that's basically the idea. We leave the atmosphere and we shoot out into nothing, and that's it. You know, we're just literally there. There is nothing. Now, obviously, you know, we have the effects of gravity, but gravity works differently. It's not just a case of pulling us towards the ground when we're up in space. It's basically you're falling forever. You don't stop falling. It's really complicated. I sort of don't fully understand it myself, but I understand it enough to sort of be able to talk about it. I mean, basically, if you're going around say you're going around the Earth in a shuttle pod, and you're literally just spinning around, and you're going in what they call a geostationary orbit. That's basically they've sent it to the point where it's going around fast enough. It's going around at the same rotational speed and the same equatorial axis as the planet Earth, but it stays over one point, and that's because it's at just the distance away enough to go at that exact speed to stay over that point. So say if the UK was to launch a satellite to carry the EE network, for example. So obviously that satellite gets shot up into the atmosphere, and it's only to work for the UK, this particular satellite. So they would fire that up from ourselves, they would get it into its orbit, and they would line it up over the UK, get it in geostationary, so it's going at the same speed, the same relative velocity as the planet Earth, and it would literally just stay over the United Kingdom and literally follow it round 24 hours a day. Obviously, you know, it's not going to last forever. You know, it'll either slow up or speed down at certain points. When the one thing that we can't do is get a perfect 0 to 0 ratio, you know, orbit. We can't get a 1,000 kilometer orbit to a 1,000 kilometer orbit. There's always going to be a slight shift one way or the other. So you'll probably end up having a 1002 to a 998, something along those lines, or maybe a 1002 to a 1,000 kilometer orbit. But that's fairly reasonable. Obviously, getting back into orbit, you then have to, you know, you probably watch Scott Manley, HFC Gaming, all of those great people who do some great things with this game, and they are actually quite an inspiration to me when I do watch them because they're very informative. Now, obviously, I am nowhere near as up in the game as Scott Manley is, and you know, that guy really, he knows his stuff. I mean, I've only watched a few of his videos, but the level of detail he goes into. I mean, he's doing calculations. He's planning the speed he needs to get through layers of atmosphere. I mean, the level of commitment from the guy is crazy. It really is. But you know, at the end of the day, that's what this game is. You know, if you don't put that level in, then you're just gonna get crashes and you're not gonna get anywhere. You know, if you want to, you know, you can load this game up for the first time, check out the map view, and think to yourself, I'm gonna do a manned mission to Lave. If you don't know about orbital mechanics, you know, and to the extent that Scott Manley does, then, you know, let's be fair, it's not something you're going to be able to complete the first time. I mean, it is something I actually would like to complete myself one day. It's one of my personal goals. I would like to get a manned mission to Lave. I mean, obviously, you know, I do understand the basics behind getting into space and travelling through space. I understand the ideas behind atmospheric braking. I also understand, you know, I understand the basics of burning retrograde, burning prograde to the target to make sure you actually, you know, you kill your relative velocity in relation to your target, so you can actually start to slow down. I understand the basics, but this game is so ridiculously complicated at that kind of level that even if you understand the theory behind it, the practicalities are completely different. But anyway, moving back to single stage to orbits, that's sort of why we don't, you know, this would be a preferable option if it was to actually work. I mean, the science behind it makes sense, but it's taking up that fuel, it's bringing that fuel back, you know. I mean, obviously, if you've got a ship in space which has got atmospheric breathing engines, then you could actually fly that out to, say, to Jupiter, or in this particular case, on this game, I think it's the gas giant. I can't remember the name of the gas giant. I think it's Elu. Don't quote me on that. But it's basically the gas giant that Lave is the parent, the parent gas giant to the moon of Lave. You could take that SSTO. If you could get it to there, obviously using your rocket engine, you could actually gain the relative velocity and sort of go for a potential capture. And then once you've got the capture, you could actually you could use the atmosphere by moving yourself into atmosphere by burning yourself retrograde relative to the target, which in this case would be the gas giant. Then you could actually go into the atmosphere, and using the top layers of the atmosphere, you could reignite those atmospheric engines and actually burn retrograde using those engines to decrease your relative velocity. Then obviously you could also use them to take off again. So if, for example, you were to land on Lave is very similar to the planet Earth in terms of its atmospheric makeup, in terms of its level of gravity. I mean, it's slightly less than Kerbal gravity, but it's a bit, you know, Kerbal gravity is about 0.3 Gs. Obviously planet Earth we have 1 G. I think Lave has, I think it's about it's like 0.25, so it's very similar. I mean, obviously if that was in relation to Wars, it would be about 0.8 Gs, something along those lines. So it's not quite what we were used to. You'd have a slight spring in your step, but obviously you've still got the effects of gravity there. So you could take this single stage to orbit, and you could land on Lave. You could run your mission. You could collect your scientific samples. You could study the plant life. You could study the local wildlife, whatever it is that you want to do. And then you could get back in the ship. You could use the atmospheric breathing engines to take off, build up speed by going round Lave, using the atmospheric engines, and then break out again using your rocket engine. And then obviously, to return to the planet Earth by that point, you would probably need a fuel refill. But just for example, say you had the fuel, you then obviously line yourself up, you burn yourself back towards Kerbal or the planet Earth, and you'd go back down, and you'd come into the orbit. You'd come into your orbit, and you'd start to, you'd burn retrograde using your rocket engine just to make that final adjustment. Bring down your periapsis, so you can actually move into the atmosphere. Move down into the atmosphere to lose some of your relative velocity. Then, as you're moving through the atmosphere and you're losing that velocity, your apoapsis is moving down. It swings around. Your periapsis becomes the opposite side. You pull that in. Then, obviously, you can actually then gradually slow down. But you can fire up those atmospheric engines, and you can gain speed. You can gain the distance you need, and you can actually fly yourself back down and hopefully land it safely. And that is why they would be a preferable option. There's so many more places they could go. There's so many more places they could actually come back from, and you'd only ever need one craft. So it's sort of something that I would like. I'd like to be able to do something with. Obviously, I've been talking for quite a while now about that subject, and quite a few things have happened in that time. Obviously, this is the design that we just finished completing here. Now, this design. Yeah, at the end of the day, I don't think this is going to go anywhere, to be quite honest. It's very wobbly, it's out of control. I mean, I don't think this design is going to get us anywhere, but I'm going to give it one more go. I'm just going to give myself some more control. I'll turn those standard canards over so they can sort of be relative to the actual lift we need. and I've also given a tail fin to it so I can sort of counteract the horizontal movement as I just sort of move along the runway if need be. So here we are, we're going in for this one more time. Now, obviously, what else did I want to talk about? The other thing I would sort of wanted to talk about is like sort of the future of the space, sort of the actual space program for the planet Earth. I mean, obviously, we've now got space stations up in our orbit. But obviously, a lot of people may have heard about Mars 1, the mission that's being privately funded by somebody who wants to actually colonize Mars. And that's actually, that's very exciting. And I've been reading a lot about that, doing a lot of other things. And obviously, that's not the only thing that we're currently looking into at the moment. We're here on the planet Earth. I mean, we're still doing our daily missions. We have the scientists up on the space stations. We have people going up and down every day. Obviously, I think the most recent thing that was in the news, I think, was that musician. He was in space for quite some time. He was on one of the space stations, and he's recently came back. I mean, we are doing a lot of interesting things, but I mean, the furthest we've got manned is our own moon, and I'm sort of hoping that we'll soon find the technology to get out beyond our own sphere of influence. Not just sticking within our own initial moon, but being able to get to Mars. Being able to land a team there, being able to possibly actually do colonize a planet. I mean, Mars is a fairly obvious option for the simple fact that. You have the addition that is nearby. If supplies were needed, it wouldn't take us that long to get them out there. We could send them up, and then obviously we could send another ship 2 years later to follow in behind that for supplies, and then another ship 2 years after that for more supplies, and it would receive, they would receive them when they needed them. So it's not like we couldn't do things like that if needed be. But it's quite an exciting project, and it's definitely one worth looking into if you are interested in that kind of thing. I mean, Mars 1, it's a very, very I think the word is it's an extravagant idea. It's the most human idea we could possibly have. Leaving our own planet and moving to a different planet. I mean, anyone who's watched Star Trek will know that the biggest dream is to get out there and actually find someone else and go somewhere else. And even if we're only going to Mars, that is a massive step. I mean, on current technology, it's going to take them quite a long time to get there. I mean, it's going to take them a good 7 years, if memory serves. But even so, it's quite impressive. But anyway, obviously we're talking a lot about space, the mechanics and everything like that. And in the background, I mean, obviously you've noticed we've just jumped and changed ship completely. And obviously, that video was just basically me failing after failing after failing after failing. So I decided to go back and actually recorded some more footage on a later date. And this is what I came up with. Originally, I didn't have this rocket on the back. But I decided, if I'm going to go single stage to orbit, and that is what we want to do, then I may as well give it a go. Because I actually did test this without the rocket on the back, and I could actually get up to the height I needed. I could build the speed. I was doing really well. I mean, obviously I had a burn, I had a spin out, but that was till I went too high into the atmosphere. That was my own, high out of the atmosphere on an atmospheric breathing engine. That was my own fault. But I didn't have any other engine to swap to. I mean, I was carrying an ion engine, but I didn't have a decent amount of electric charge to run the ion engine for very long. And I had plenty of xenon gas. I'd mounted that on. You can actually see because I left the xenon gas in there. I mainly left that in there as balance. As ballast. I sort of balanced the weight out because the front of the plane would have been very, very light if it didn't have some form of weight in there. So that's why the xenon gas is still in there underneath those wings. Now, obviously, I sort of designed this to be carrying something in that space there, and that's where I thought, well, the rocket could be there. And my original idea was to put the rocket in there on a actual detachment manifold, and then obviously, if need be, I could detach it. Now, obviously, this is one of the last attempts I had to try and fly this. As you can see there, I tried to level out so I could start getting some horizontal speed because I was coming up to pardon me, the 10,000 meter mark, where I could have done with being a bit more horizontal, a bit more leant over, starting to build that speed up. But obviously, the weight of the rocket mounted onto the back is actually making it impossible for me to actually tilt the thing beyond the direction it's currently going in. And here I am, I'm fighting to get back into control. I'm trying to turn, I'm trying flat spin, I'm trying everything I possibly can to get sub-level control back. And in the end, I decide to, you know what, launch the rocket on the back. It's obviously not going to save us, but it might just give me the level of control I need to hopefully pull this out, and it doesn't be crash into the ground. That's everything for today, my fellow activists. I hope you enjoyed the episode, and we'll see you all next time. Bye for now.